So the circus wants to sell t-shirts and hats. Shirts are $30. Hats are $25. Write the function that represents revenue in 1 week if X represents the number of hats and Y is the number of shirts. So X is hats. Y is shirts. Hats are $25. Shirts are $30. That's everything we need to know to get started. So revenue is 25x plus 30y. So there's our revenue equation. Now from the constraints, that's all their inequalities that we have to graph to get the region and all the vertices and all that stuff. So can have no more than 90 t-shirts and hats in stock at one time. So that means hats plus t-shirts. Hats plus t-shirts. X plus Y. No more than 90, so less than or equal to 90. It takes a quarter of an hour to make a shirt and a half an hour to make a hat. And there's 25 available hours in 1 week. So quarter of an hour to make a t-shirt, which is Y, plus a half an hour to make a hat, which is X. And it has 25 hours, so it has to be less than or equal to 25. There must be at least 5 hats. So hats is at least 5. X is greater than or equal to 5. And at least 20 t-shirts. So Y for t-shirts is greater than or equal to 20. And they can sell up to 35 hats, which means X for hats is less than or equal to 35. So we've got 5 equations. 1, 2, 3, 4, 5 equations. We've got to graph all of them and find the vertices. So we have X is greater than or equal to 5. Y is greater than or equal to 20. So disappear. X up to 35, so less than or equal to 35. So let's count by 5s, maybe. So if we have this graph, there's our y-axis, there's our x-axis. About 20, so is that enough? No. I'll count by 5s. So counting by 5s, we need to graph our first one at X is greater than or equal to 5. So that's the first line. X is greater than or equal to 5. On the right side, because greater than will be going to the right. 10, 20, 30, 40. Counting by 5s. So I labeled every other one for 10s. Then we have X is less than or equal to 35. So here's another line at 35. Less than or equal to, so that's going to the left. Y is greater than or equal to 20. 5, 10, 15, 20. Greater than or equal to, so it needs to be in there. did that one, we did that one, we did that one. X plus y is less than or equal to 90. So count out to 90 on each axis. 60, 70, 80. There's 90. It's going to intercept 90 and 90 up here. So graph it from 90 to 90, those two dots that we drew. And it needs to be less than that graph. So we're looking still underneath that graph. So we're still in this little region. Got one more equation we need to graph, the 1/4 y. So let's get that to slope-intercept form to finish this off. It's going to be less than or equal to negative 1/2 x plus 25. And then multiply everything by 4. So you get y is less than or equal to negative 4 over 2 is negative 2x plus 100. When you graph that, starts at the y-intercept of 100, goes down 2 over 1, so it's going to go down 100 and over 50. It'll end right there. And that is also a less than equation. So it was inside this region, also needs to be less than this line, so we have this weird shape. So we need all the vertices. There's an easy one, there's an easy one. That one's not so easy. So we need all those vertices. An easy way to get all those vertices, if your sketch isn't quite clear, is use your graphing calculator. We're going to graph y is greater than or equal to 20. Y, we're going to graph 20. We're also going to graph this one, so y equals negative x plus 90. And y equals negative 2x plus 100. You do need to change your window because we knew that it went from 0 . We did 100 for both x's and y's. Now you can see pretty much all of your intersections. If you go G-solve, intersect, you have to pick which lines you want it to intersect. So we're going to pick the negative x plus 90 and the negative 2x plus 100. The 1080. So this one right here that we were looking for is at 1080. These ones down here are pretty easy to see because that's at 520. This one's at 3520. This one's at 35 something. Looks like 30. We can get it for sure from the calculator if you just go gsolve. We want the y value, so y calc. You have to pick which graph we're looking for, which is, we're looking at this line right here, which we're on now. It's y3. And the x value we're looking for is 35, which is 30, which is what it looks like, 35, 30. You do the same thing over here. When x is 5, you can figure out what it is. You could also just plug it in, but it's going down 1 over 1 all the way through. So that last point right there is 585. So there's all your vertices. 1, 2, 3, 4, 5 of them. Identify the vertices, and then the maximum revenue, we got to plug that, each of those vertices into 25x plus 30y. We plug it into 25x plus 30y. We're plugging in 520. We're plugging in 3520, 3530, 585, and 1080. So plug in 5 for x, 20 for y, get an answer for all 5 vertices. So you plug in all those numbers, you get 725, 1,475, 1,775, 2,675, and 2,650. Question said to find the maximum revenue and how many hats and shirts. So the maximum, that's the biggest, that's right here, 2,675, and that's when there's 5 and 85. So the maximum revenue is 2,675 for 5 X's hats. So 5 hats and 85 shirts.